Hi, today we'll look at how to create a MapReduce program with an IDE, and in specific we are going to look at uh, Eclipse IDE and how to set up a program, and finally we'll see how to execute the MapReduce program within your IDE. So let's get started. So the agenda here is first we'll look at the basic requirements or the basic software that you need to have to create the MapReduce program, execute that. Secondly, we'll open the IDE, and here today we'll look at Eclipse IDE, but the setup procedure is similar to other IDEs as well, like IntelliJ. And thirdly, once we create the program, we'll also look at the basic libraries that are required, which are needed for the IDE to execute the MapReduce program. So let's get started. So the first requirement here is you need to have a Hadoop system running. So you may have downloaded it. You may have downloaded the tarball and manually installed it, which is fine. Or if you don't want to go through the pain, you can also download the Cloudera virtual machine or virtual machines from MapR or Hortonworks, because they support the same. They have the same software stack. So here you can see I have the Cloudera VM running on my system. And for people who are not aware of how to install the Cloudera in your virtual machine, please watch my previous videos on how to download and install virtual machine, specifically Cloudera, into the virtual box or VMware, which you can find in my channel. So here I am running Hadoop version 2. You can confirm that. So this is Hadoop version 2.0.0 running on CDH or Cloudera Manager 4.0.0. Okay. And here, as you can see, Eclipse is available on the Cloudera itself, so you don't have to install any other software. So all the software that is required is right in the virtual machine. And here is my Eclipse IDE. So let's see how to create a MapReduce program from the scratch and how to execute that on a standalone IDE without having access to the Hadoop system. So most of the Hadoop developers, they use various IDEs and they develop their programs, they test it on their integrated environments before pushing on to their testing or pre-production systems. So first thing or the first step here is to create a project. So that you can do by going to the File, New, Java Project. And let's start with the word count. And word count is a basic example in Hadoop world, which is similar to your Hello World programs. And here you can see that it automatically picks up the various JREs that are available in your system. And I'm using Java Standard Edition 1.7. Click Next. And here it's going to automatically create few directories for you, like the SRC directory. And you can see there are various tabs like projects, which we'll look at in later examples, and the various libraries. So because we are going to execute our MapReduce program within the development environment, We want to also add few external jars so that the program recognizes the various paths and the various imports and there are no errors. Here what you can do is click on the Add External JRs tab. And the first thing is I'll go to File System, USR, which is user lib hadoop, and I'm going to pick some of these here, like the hadoop common.jar, auth, and the annotations. Similarly, I'm going to add few more here, and now I'll go to /user/lib/hadoop client -0.2.0. By default, what I do is I pick up everything from this location so that I don't have to worry about specific libraries. And thirdly, I'll go back to the same add external jars, go to /user lib hadoop and lib, and pull out one specific jar from here. So you can add sl f4j.jar, so this is the simple logging facade for Java, or sl f4j. I'm going to add common HTTP client. That should work. And now I can click on the finish button here. It's going to create the project. Okay. So now once you expand your project, as part of this project, you can see that all the libraries that you have added will be displayed under the project. But in real production, you don't have to do that. You have to either build or create a build.xml if you're using Ant, or if you're using Maven, you can create form.xml, which we'll talk in the later upcoming videos. So now I can just select src here, go to the file, new, package, and I'll give the package name as com.bigdata101. And here you can see my package is created. Okay. So as you can see, I have created the package here, and packages are specifically created when you want to separate out your code. So this is like having a separate namespace. It is easier to distribute your code, manage your code, etc. And once your package is created, you can go to the file, new, and you can say new class, and I can give a name as what count. So as you can see, the source folder is automatically generated, the package is automatically pulled out, and the name is something which we gave it. And just select, by default the public is selected, click on the finish. Okay, and as you can see, the basic construct is already available. And what I'm going to do is I already have code here, which I'm going to select and replace it. Okay, so I copied my code here and saved it. Let's quickly check if there are any errors. Okay, so there are no errors here. So I'm going to quickly run through some of the lines here. Okay, so I'm not going to go through each and every line, but I'll explain what we are trying to do here. So this is a simple word count program which is going to look at an input file or an input directory, and for each file it's going to read the data that is there, and finally it's going to say how many times a particular word was found in the input file, right, or input files. So the first line is the package, right, which I said is like a namespace. Then I have few imports from the Java input, output, and the utility packages, specifically the input, output, exception, iterator, and the string tokenizer. So this is basically to split the lines using a specific delimiter. And next we see some imports which are specific to Hadoop, like fs.path, which is going to read the files from the input or write the files to a specific output. Then int writable and long writable text. These three are the data types that are available in Hadoop. And we are going to import few file formats, input format and output format, right? Job configuration, client, the mapper, reducer, and the specific input and output formats. And in specific, we are going to use only the text input and the text output in this example. And here is my main class, which is word count. And first thing to remember is every MapReduce program that you create will have three methods, right? So first is the map method, where the specific data is mapped, right, or filtered from the specific input file provided by the user. Second one is the reducer. So reducer is like a summarization step or an execution step, which is going to combine multiple things together and give the final output to you. There's a second class. And third one is nothing but the driver. So the selected part is the driver. So which is where all the mapper and the reducer is called. The specific input format is specified along with output format, and the various input paths are also specified here, like the input and output paths. So as you can see, I have put everything or the three main classes into a single file, right? But in general, if you find it much easier, you can just pull out the mapper into a separate word count mapper.java. You can pull out reducer into word count reducer.java, and you can name your the driver as the word count.java. Okay, so based on the complexity of the program, you can segregate it out, and because it's here is a very small program, I put everything into a single Java file. Okay, so I don't see any errors in the program. Now how do we run this program, right? So before I put this onto a QS box for my QA people to test, I need to make sure that it's working as per the expected logic. So let me see if I have any input files here before I start on. Okay, so here is an input directory and input file on my local file system. So many people get confused between local file system and Hadoop file system. So this is on my local file system. I put this on the local file system because your IDE cannot talk to the Hadoop file system, right? And this sample file contains some random data here. The phase scheduler allows administrators to configure policies and blah blah blah. So what the mapper is going to do is it's going to read each line. So let me go back to the code. So here my mapper is going to read each line by line, right? So as you can see here, I have just one line, but your input file can have multiple lines. Now it's going to convert to a string, and using the Java string tokenizer, it's going to break the words from their lines into a tokenizer array. So what happens is when this line is broken, so we'll have the phase scheduler and individual words together. And finally it is going to loop over the tokenizer array and write the word and with a number comma 1. So here is just filtering it out and identifying what words are there, which is a very simple logic. And coming to the reducer is where the data is aggregated or summarized before writing to the final output. So in the real world, mapper output is only written to the temporary location of HDFS, and that is removed once your complete MapReduce job is done. And the final output is only written to HDFS from the reducer. And here you can see my logic of reducer is also very simple, which is initializing a variable called sum equal to 0, and it is looping the values which is being passed to the reducer. So I'm going to get a key, which is actual word, and the values, which is basically 1 comma 1. So if there is a word which appeared twice, it will have 1 comma 1. And if there's a word which appeared thrice, so we'll have the word here, and so let's say administrator, it will have 1 comma 1, for example. And here we are just going to aggregate all the values together. So in this case, administrator output will be administrator, comma 2. And finally, it's going to write the output to my HDFS location, right? But from the IDE, it's going to write to the path which I'm going to specify. And coming to driver class, this is your glue, and this is the guy which is going to create a client, job client, and the job client is going to interact with your MapReduce program and also the job tracker. And here you can see we are setting up a job name called word count. So this is just a name to identify this particular job later in the MapReduce tracker page. And you also need to specify multiple things like what's output key class and output value class. So basically my output key class will be handled by text.class and output value will be handled by the int writable, because as I'm going to write the int values. Similarly, we need to specify the mapper class name, the reducer class name, and the combiner class. So combiner class we'll discuss in the next session. And finally, you also need to specify what's the input type format and what's the output format. So by default, text input and text output format are used by Hadoop, but if you are using or processing binary data like video, audio, or image, then you can use the sequence file format, which is the high performance binary format created for Hadoop. Okay, so let's now execute this program and see the output. So let me get the path from my local file system. So to execute the program within your IDE, go to your project, right click and select Run as Run Configurations. And here you can see the project might be a different one, right? If you executed previous one. So you can select your project here from the browse. And similarly the class, you can hit a search button. And I just type my class name and it found out that's from the form.bigdata101 package. And the next important point is, so let's change this name to account. Let's go to the arguments tab. And here, as you can see, I've specified two inputs here. So first is my input from the local file system where my sample file is there. So you can also specify a single file, or if you have multiple files in directory, you can just specify the directory. Your program will pick up all the input files from that directory and process each one by one. So in our case, let's give a file name which is sample. And finally, I want this guy to write the output to my local file system into this tab. And if you want to specify any VM arguments, you can specify. So I don't have to specify anything in my example. And you don't need to change the JRE path. By default, it picks up the 1.7. And class path, I don't need to because everything is, all the entries are there in my class path. Then you hit apply and run. So this should open the debug window. And as you can see, my program has successfully executed. Okay. So if you look at the output, you can see that it uses the file input format to read one input file. And here my mapper task has started. I can say it's a mapper task because there's a M in the process of the job. Then once it is done, it has started the reduce task. And you can see that all this process running under a local job runner mode, which is reading the file. And finally, it has finished my job here. And it has saved the output in this particular location, which is one of the arguments which are specified. And finally, these are the various MapReduce counters the job is going to print, like the number of bytes it has read, what's the MapReduce, the input records, output records, the combined, the reduce input records and the reduce output records. So let's go and see the output, how it looks like. Okay, so as you can see, it says the word fair has been found once and was found twice. And similarly, the string or the word the was found 4 times. So this is a basic word count program and a complete demo of how to create a project in Eclipse, how to set up your code, right? And then how to execute and test it before pushing on to your QA team. So that's it, folks. So I'll come up with another video next time with a new topic. Thanks for watching.